Moving on to the next part of today's event, we have a tech talk which is being presented by Ravi Lakkaraju, who has been a Hyderabad native and who has been with Infosys for 2 decades. He has extensive experience in AI, RPA, and data analytics, and leads several RPA data modernization and AI-led QE projects across different domains. In his current role, he's managing an AI Center for Excellence, where he's instrumental in driving and implementing the adoption of AI in quality engineering across clients and geographies. So can I please invite Ravi Lakkaraju onto the stage?
Good evening, everyone. I'm a career tester. So all 2 decades I'm into testing. I've seen in my career different. I was talking to Ashwin. In my career, I've seen different instances where the quality has been questioned. There was automation wave where they were saying no, quality team will go away, and then we had a DevOps where their quality team has been questioned, and now you see AI wave. Now again the quality is being questioned. But in my experience, I've seen whenever such debate comes, the quality has increased. I think I see similar opportunity with the new wave, AI first. I think we have seen 3 trends in last few years, right? We have digital first wave, then we have a cloud wave, and today we are talking about AI first, especially with the launch of ChatGPT 3, a lot of excitement and discussion have started. So I'll share my experience in this area and hope you'll take a few ideas and end of the session. So this whole AI is opening up 2 opportunities for a quality engineering team. So one, these AI systems are complex. There are a lot of failure points. In fact, I was debating, I think there was a discussion now this new GenAI can do coding, new GenAI can write documents, everything it can do. And said the only testing will remain, who will test it? There's so many failure points, so much of compliance. So that's a lot of big opportunity that is going to open up in a quality engineering. But that's not the topic of discussion. Today, we will focus how do we leverage AI in quality engineering. As is in the earlier session, Santanu was talking about, can bots and testers go together? If so, to what extent? Right? I think that's a topic of today. So I'll share my experience in this area. Recently, I think again, every quality head was talking about, Ravi, we have this new LLMs, generative AI, GPT-3, every hyperscalers have launched, and they are such a powerful. So one of the quality head was asking, Ravi, why don't you use these tools and replace 70% of the quality team with AI bots? Right? So then I was thinking, is it possible? If so, to what extent we can replace the quality team with new AI bots? Because we are seeing now it can write test cases, it can generate test data, it can generate automation scripts, whatnot. So now the last few quarters, I've done a lot of pilots, I've done a few implementation. With that experience, I can say that's an aspiration, right? If I take that as an end state where I want to replace 70% of the workforce with AI bots and divide that journey into 4 phases, I would say today we are in the second phase. So I'll explain more in detail. Right, the first phase, I'll call it as optimize AI. Right, most of you have already tried, where we have used classical AI solutions, right, using machine learning and the cognitive capabilities. We have solved many AI problems, right? So I think we have done optimization of test cases with AI. So we have done optimization of your maintaining with self-healing capabilities, right? And defect analytics, the intelligent dashboards. So there were many problems we were able, and they are successful, stable, which we were able to solve through classical AI. When I say classical AI, era before generative AI, you're able to use the machine learning or a deep learning capabilities or a cognitive capabilities. Or so basically, that first wave helped us optimize what we're already doing in a quality engineering. right? So you already had a test cases. Now using AI, I'm able to optimize how many test cases I can execute in the iteration. I was able to bring down that self-service orchestration in the quality organization, right? I was able to predict the defects, right? I was able to self-heal the automation script. So and so capability, I'm sure all of you have tried those use cases and they're successful. Now today, we are in the second phase of the AI journey, and I would call it as Assist AI. I'll explain why I'm using Assist. Now all of you would have tried some or other generative AI. So it opened up a lot of new capabilities in a quality engineering space. So first one, straightforward. No, I can take any large language model. I can take GPT-3, or you can take AWS Titan, or the Google model, whatever. Write prompts. It has certain capabilities, default capabilities, right? Again, there's a lot of theory around what kind of prompts, how to write prompts, but it provides you it can solve certain problems. The problems like I can do now code conversion, right? If you want to migrate from a commercial automation tool, example test complete to Selenium or UFT to Selenium, that can be done very conveniently with the vanilla large. If I use the word vanilla large language model, what I mean is use any of this commercial or open source large language model, right? It can help you in case if it is a modernization project and you want to understand the legacy code, it can be done very easily with any of this model using prompts. It can help you to generate to certain level synthetic test data generation. One of the participant was asking so and so use cases. I think that is no brainer. All of you would have tried to some level using prompts. But more successful and large scale implementation I've seen is using large language model with a RAG technique, right? So any use cases with large language model with a RAG fusion and the similar frameworks, you will see more success. The use cases will be today, I'll give an example, right? So today, I can go to any quality organization, I can take all their repositories. Look, as a quality team, we generate a lot of content, right? Over years, this quality is like, I'm there in this industry for two decades. So I've been generating for every organization so much of content. Can I take all that content? Can I take all that user guides, scroll through the applications and extract some information, all that information, create a knowledge foundation model with a combination of LLM and RAG technique. Once that is implemented, user can come there, provide a user story and generate test cases, right? User can come there, if it is a newcomer, he will be able to generate a training material, right? Or you can build a defect lineage from that knowledge foundation model. This is a very successful technique which has been used outside the quality engineering, and I found similar results in the quality engineering space. This is something all of you should try about, right? So this is the second technique and the use cases around that. And the third one is, again, the pair programmer. Third use cases, again, pair programmer, all of you would have tried. I've interacted with many automation experts, and many of tell Ravi, if I given access to pair programmer, I can do work faster, right? I think that's again a very successful GenAI story. And the fourth one, if you're not able to solve through prompts, you're not able to solve through your RAG technique, if you're not able to solve through your pair programmer, I think the fourth technique, we have to rely on the fine tuning. Basically, you pick up any offline LLM or commercial LLM. Again, commercial LLM has certain limitation, but you can pick up any offline LLM like Llama, Falcon, or Mistral, any of the LLM, fine tune the data and make it understand your applications, right? These are the four techniques. Now why did I call it as Assist AI, right? I'll come to, then very important you understand what are the limitations, again, based on my experience, what are the limitations or what are the boundaries of this generative AI? The first limitation I observed is in terms of how do we treat the accuracy part. Let me give an example. So I was asking, I've created a wonderful large language model and it is started throwing test cases given a user story. And I was saying it is a 40% accuracy. So what do you mean by 40% accuracy? 40% of work done and I have to do the rest of the 60%? Is that the understanding? Is that 40% means 40% of my problem solved and I have to do the balance 60%? No. 40% accurate, assuming it is throwing 500 test cases, which 40% of the test case is accurate, right? Okay, I will open up the test case, it has some 40 lines, which 40 lines, 40% of those 40 lines is accurate? Which means a tester has to go through each and every line and understand which is accurate, which is not accurate, and edit it. It's too much of effort. So that's one of the main roadblock I observe. Any generative AI for a high volume data with a low accuracy, don't even go for it. It doesn't work. You spend more effort than that. But it works at a very small chunks of data. Example, I'm a tester. A foundation model is throwing up, give me a template or a scenario of business scenarios. What I'll have to do is take the template, fill in the steps. I'm doing then and there, right? I know what is valid in those 10 steps. I have to just update the rest of the steps and launch it. Same with pair programmer, right? If you large language model throwing up your some 100 automation scripts, which line is accurate, which line is not accurate. So too much of effort. But if I use a pair programmer on day-to-day use, it is throwing a few lines of code, then and there I edit it, I consume it works, right? So it's very important. Accuracy is a very important factor. Low accuracy, bulk generation, it is going to be a failed use case. But low accuracy at a smaller chunks of work, it works well, right? That's one roadblock. Now, second roadblock, I've seen ability of this large language model to handle complex use cases. Let's take, I'm sure most of you would have tried pair programmer. It generates a good amount of Selenium code, UFT code. But can pair programmer understand your existing framework? No, right? And that's where roadblock, we already would have invested in a framework, right? And framework, this pair programmer like Copilot has no clue what are the functions, what are the components in those existing framework, right? So similarly, I've built a foundation model. It can generate the test cases for an application, but ask it to generate test cases for an end-to-end application. It hallucinates, right? So that's a second main problem to a complex use cases. The outcome, the hallucination is very high, so it works fantastically to smaller chunks of work. That is the reason I said in the beginning, it is assist AI. It will assist you, right? Use any large language model to assist you in writing the test cases. It can assist you in generating the test data, but it cannot replace complete test generation activity by LLM model. I think we are not at that phase, right? So that's the second challenge. And the third challenge, most of you would not have faced, at least I have seen that eventually all of you would face similar challenge. Today there is no portability of LLM. Example I was talking about, I'll pick any of the offline model like Llama or something, I will fine tune it with all my existing Selenium code or test cases. There's so many models and someone will come say, no, Llama, you go to Mistral. What should I do? All my hardware cost, because you spend a lot of hardware cost, a lot of GPU goes to it. All my hardware cost, all my effort goes waste. I have to redo that activity again. So today there is no portability if you're getting into a fine-tuning technique. So anything around fine-tuning, you may not see good ROI. It's more of an experimentation. I'm talking within the quality engineering, right? I'm not talking about use cases outside quality engineering, but within quality engineering, any use cases around fine-tuning, you will not see ROI. You may get results, but you have to keep shifting to one, you keep trying one model to other model, right? So with these challenges, I think in the second phase of AI journey, it is assisting the quality engineering, right? You can do work faster. If you have a pair programmer, you can do work faster. If you have a knowledge foundation model, you can generate test case faster. But still you need tester who can understand them, edit it then and there and move it, right? So that's the second phase. I am foreseeing the third phase where it will be augment AI, where I'm expecting these models will be more mature, there will be a feedback loop. Today, there is no easy technique where I'll go to any of these large language models and say, boss, this 40 test case is wrong, go learn from it, There is no easy technique. Only technique was fine tuning. I've told you what are the limitations, right? So I'm assuming there'll be better, easy technique in the next phase, where at least some of the tasks are completely 100% taken over by AI. So that's the third phase. I'm foreseeing it. I think we have to reach. And the final stage, able to orchestrate all this end-to-end, at least replace 70% of the workforce by quality engineer. As I told you, it's an aspiration. I think long way to go.
So I want you to tell me how we will ensure that the Gen AI will not be able to replace 70% of our workforce. What do we have to do to prepare the workforce for this? So ultimately, we need those jobs, and I'm very keen to protect all the jobs.
Yeah, Manisha, I was highlighting that it is.
Repeat the question so the audience will
The question was, what should we do not to reach this 70% bots replacing quality engineers, right? Again, I was saying beginning of the session, I'm a career tester. We have seen such debates again and again during automation wave, DevOps wave. Now testers will go away, and every time we are seeing it is growing, right? I think this is opening up a lot of new opportunities. You see a lot of bots getting implemented in the production. There's a lot of failure points, a lot of complexity, complaints. So it is opening up a lot of new testing opportunities, right? And at the same time, as I told you, we are in the second phase. Bots really stable with a higher accuracy, because the tolerance in testing is 0% for failure, right? We cannot run a testing program with 80% accuracy. So we need something which is 100% accurate. I think there's a lot to catch up there. Yeah.
Okay, I have a question. Hi,
Yeah.
I'm Resh Kumar. I'm coming from Equifax. And so my question is, we have been trying to implement AI and this kind of generative AI for our testing, right? And we have always faced a lot of roadblocks from the security. So my question to you is like, did you face these kind of challenges from security and compliance, and like, what was your approach in addressing those challenges?
Yeah. No, that's a common. I think I missed that point. I think I assumed basically. Look, the challenges is in terms of security compliance is usage of commercial large language models, right? If I have to use Azure OpenAI, Azure GPT-4 models, or AWS Titan, or any of the Google models, data goes outside your network, right? So alternative to use open source offline commercial model like Llama, Falcon. There are many models and different variants also there. You have a contest models we should use, and data stays within your network.
Okay. And my next question is like with respect to quantum computing, right? So do you think that there will be like an exponential growth in terms of processing power and like in terms of the proliferation of this into all the rest of the fields in IT because of quantum computing, and how long do you think that we're going to really see some impacts of quantum computing?
I was also thinking in similar lines. What is the next wave? So cloud wave has ended, AI has started. I think there's a lot to mint in AI wave. I think once that stops, quantum computing will start. I think there's some time.
So what do you think about testing the AI itself? Right? Do we have like a framework or thought process around testing, like how effective AI itself is? Like your question about like the 40% of the test good and the 60% is not good, right? So is there any process like do we test the AI scripts that we generate itself?
You're talking about testing AI systems?
AI scripts, the outcome of AI. So
Yeah, as I'm telling, at a smaller chunks, it works fantastic, right? Because you get the script then and there, edit it, modify it. But you do a bulk job, giving basically handover, replace you with a bot, it's a risky as of today, because of the kind of accuracy it is throwing, right? As I'm telling, you cannot run a quality organization with 40-50% accuracy. We are there to 100% accuracy, right? No defect slippages. I think that's our end goal. All this, so any hallucination, I think it won't fly.